Hello students, welcome to Breedmark Academy. Myself LS Nanda. In today's video, I am going to discuss the solution of a mathematics question that was asked in one of the shifts of JEE Main 2025 April session exam. Now students, I will make a separate playlist that will contain the video solutions of best selected problems from JEE Main 2025 April session exam. You can just check out that playlist and watch those videos. Now today's question is in front of you. This question is based on the topic of inverse trigonometry. We have to find the value of cot inverse of 7 upon 4 plus cot inverse of 19 upon 4 plus cot inverse of 39 upon 4 and so on till infinity. Now students, we know that cot inverse x is equal to tan inverse of 1 upon x when x is positive. So that means the above series can be rewritten as tan inverse of 4 upon 7 plus tan inverse of 4 upon 19 plus tan inverse of 4 upon 39 and so on till infinity. Now students, if you just look at the fractions inside every tan inverse function that is written here, then every fraction has numerator as 4, but the denominators of these fractions are 7, 19, 39 and so on. They are clearly forming a different series because the difference of 19 and 7 is 12. The difference of 39 and 19 is 20. So similarly, we can conclude that the next term will be 39 plus 28 because every time in the difference 8 is being added up. So 39 plus 28, the next term will become 67 and so on. It would have been better if they had given one more term, but still we can judge what type of series is this. Now students, we will now find the general term of this sequence. To find the rth term or general term of this series, I will write the sum of this sequence as s equal to 7 plus 19 plus 39 plus 67 plus and so on till tr. Now we will write s again, but this time on the right hand side, I will shift every term one place to the right hand side because my intention is to subtract both of these equations. That is, now I will subtract equation number 2 from equation number 1. Now students, we move further. Now students, when I subtract the second equation from the first equation, I get 0 equal to 7 plus, I am putting a bracket here. Inside the bracket, I get 12 plus 20 plus 28. You can clearly see that all the terms inside the bracket are going to form an arithmetic progression with the first term as 12 and common difference as 8. And the last term of this AP is going to be TR minus 1. So that is just the R minus 1th term of this AP. And outside the bracket, we have minus TR. So from here, I get TR equal to 7 plus. Now students, we have to find the sum of this AP. So just apply the formula. It becomes R minus 1 whole divided by 2 into 2 times 12, which is 24, plus R minus 1 minus 1, which becomes R minus 2 into 8. And this becomes 7 plus R minus 1 whole divided by 2 into 8R plus 8. Now upon simplification, this becomes 7 plus 4 times R square minus 1. And this is just 4R square plus 3. Now we have got the general term of the sequence. So now the original series can be written as summation r varying from 1 to infinity tan inverse of 4 upon 4r square plus 3. And this can further be written as summation r varying from 1 to infinity inside the function tan inverse, just divide up and down by 4. It becomes 1 upon r square plus 3 upon 4. Now this can be further written as summation r varying from 1 to infinity. Now students, I want to give it the shape of a formula. We remember that tan inverse x minus y upon 1 plus xy is equal to tan inverse x minus tan inverse y when xy is greater than minus 1. And mostly in such kind of sequences, we have to express every term as the difference of two terms. So this is the most suitable formula over here. But to create this formula, we will have to do some adjustment in the denominator. So what I am doing, this 3 by 4 I am writing as 1 minus 1 upon 4. So now it becomes 1 plus r square minus 1 upon 4. This can further be written as summation r varying from 1 to infinity tan inverse of 1 upon 1 plus. Now r square minus 1 upon 4 can be factorized as r minus 1 upon 2 into r plus 1 upon 2. Right? Now students, we move further and find the sum of this series. Now students, this series can further be written as summation r varying from 1 to infinity tan inverse of. Now the numerator is 1, which can be written as r plus half inside the bracket minus r minus half inside the bracket. In the denominator we have 1 plus r plus half inside the bracket into r minus half inside the bracket. Now students, at this stage, we can apply the formula tan inverse x minus y upon 1 plus xy equal to tan inverse x minus tan inverse y when xy is greater than minus 1. Why? Because both of the terms r plus half and r minus half, which are acting as x and y, they are positive. So obviously their product is greater than minus 1. So now I can write this series as summation r varying from 1 to infinity tan inverse of r plus half minus tan inverse of r minus half. Right? Now students, this series can further be written as limit n tending to infinity summation r varying from 1 to n tan inverse of r plus half minus tan inverse of r minus half. That means firstly we will find the sum of first n terms of this series, and then we will find the limit of that sum when n approaches infinity. Now if I find the sum of the series summation r varying from 1 to n tan inverse of r plus half minus tan inverse of r minus half, then I can find the sum of this series by putting different values of r starting from 1. First time we will put r as 1, then r as 2, then r as 3, and so on till n. Now students, we find the sum of this series. Now students, the sum of the series till first n terms, that is summation r varying from 1 to n tan inverse r plus half minus tan inverse r minus half becomes equal to, now the first term of the series becomes tan inverse 3 by 2 minus tan inverse half when we put r as 1 The second term of the series become tan inverse 5 by 2 minus tan inverse 3 by 2 when we put r as 2. The third term of the series become tan inverse 7 by 2 minus tan inverse 5 by 2 when we put r as 3. And the nth term of the series become tan inverse n plus half minus tan inverse n minus half. Right? Now students, you can clearly see all the terms except minus tan inverse half and tan inverse n plus half, they will get cancelled, because tan inverse 3 by 2 and minus tan inverse 3 by 2, they will cancel each other. Tan inverse 5 by 2 and minus tan inverse 5 by 2, they will cancel each other, and so on. So the sum of the series till n terms becomes tan inverse n plus half minus tan inverse half. Now students, we will find the limit of this sum when n approaches infinity. And this is the final answer. Now when we put n as infinity, it becomes tan inverse infinity, which is nothing but pi by 2. And then we have minus tan inverse 1 by 2. So it becomes cot inverse 1 by 2, because pi by 2 minus tan inverse x is equal to cot inverse x. So students, option B is the correct one. Now next question related to JEE Main 2025 April session, I will post in tomorrow's video. Till then, goodbye. Keep watching my videos and enhance your knowledge of mathematics. Thanks.